In this video we will discuss state controllability and observability, and at the first thing we would like to know what's actually meant by that. We will start with the part controllability. What's meant by that? That means, is it possible to steer a system from a given point to a desired point with a finite amount of time? So yeah, that's actually it, and should be easy to understand. So it's the possibility. So that's actually meant by the part controllability. And what's meant by observability? And that's what we would what we want to discuss in here. And that says, is it possible to determine the state of a dynamic system from the observations of output and control vectors? So it means from the observed output and control vectors. Okay, that's actually it. What kind of system do we want to look at? Yeah, we will write down the state representation of a system to analyze this. So state representation is shown in literature and here as well. So A times X plus B times U and Y. So the output vector is C times X plus D times U, and X and U are both time dependent. Yeah, that's actually the state representation that you should already know about. And well, the thing what we need to know about the controllability is that we say there's a given formulation. So we will write down the rank of B, A, B, and we will do it until A to the power of n minus 1 times B. And this rank of the resulting matrix shall be n. And when this rank is held, we can say that the state is controllable. Yeah, what does this answer means? It says nothing about how to do it, how easy is it to control the system on that point. It just says it is controllable. So that might be a bottleneck of this definition. That's the first part. For the observability, we have a different description, and there we say that the rank of the matrix C times A and C times A to the power of n minus 1. This rank shall be n as well, and then we can say that the system is observable from our definition point of view. All right. Yeah, the things we already mentioned, that the controllability part, it says nothing about how the states behave at earlier and later times. It just reveals information about a given time point. That's the first point. So and how the states behave. That's the first point. Second point to mention is that required inputs may be very large with sudden changes. Might be very large with sudden changes. Third point to mention is some of the states might not be of practical importance. So it's more or less a mathematical result, but no practical result. And the last point we want to say about the controllability result is that the definition is an existence result, as already mentioned, but it does not provide a degree of controllability. So is it easy to control this point, or is it difficult? Is it more or less, just slightly controllable? So it does not provide us a degree of controllability. Okay, those are the points we want to mention about controllability. For observability, that might be of a different result. So what would we like to write down for observability? The concept is of high importance, so it's very important, because in practice there's a difficulty encountered. Yeah, and now let's write down 2 points for the observability part. One thing is that it is of high importance overall. Question is why? Why is this? The thing is, in practical usage, you have some state variables that are not accessible by direct measurement, and yeah, therefore you need this observability result. All right. This is the theory part, and in the next video we would like to have some more practical examples that reveal us some results. Now we want to analyze some examples to give you a representation of how should it look like in a practical way. For this we will write down examples. We will imagine a coefficient matrix A, and let it be 1, 1, 0, minus 1, and B shall be 1 and 0. Okay. And what we do right now is we will analyze the rank of B and AB, and when we do this is something you can do in MATLAB easily. So this coefficient matrix would be 1, 1, 0, 0. And the rank of such a matrix is clearly less than 2, so we have no full rank, and therefore we can say this system is controllable. All right, this is what we have. And for the observability part, we will analyze So we first need another example. Let's imagine A and let it be 0, 1, 0, 0, 0, 1, and then -6, -11, -6, and the coefficient C shall be 4, 5, 1. And what we do now is we say we have to build this this matrix first. This will be C, CA, and since we have 3 rows and 3 columns and 3 inputs from C, we will have CA squared as well. And which is actually 3, so n minus 1. This fits perfectly. So, and then we will analyze this rank of this matrix. You can do this in MATLAB. It just takes 2 lines of code, and we will get a rank of 2. And this rank is is not free, what we would expect, and therefore we say that this system is not observable.